Hello everybody and welcome back. Today we're gonna be looking at the next version of the enemy. We have a scene here set up. We have a spawner that's constantly spawning up to 5 enemies at a time. We're gonna go and provoke one of them. You can see here I provoke this one. It's gonna chase me. Let's move here into the view of the camera. You can see it's coming about. It's gonna attack. It's gonna hit me. You may not be able to see, but I have here in my hand, I can see my health is at 80 right now, and when he hits me it's at 70. Now I can hit him, and then boom, we have a death animation, and he actually spawns. A little bit of treasure. Let's see that again. Another enemy found me. Here chasing me. Let's go back to the camera. Attack again. Evade that one. Oof, that one hit me. Trying to hit him with the sword. Oof, and bam, got him again. And spawned some treasure. You can see these two here. Poke. Huh. Oh, he found me. No. Alright. You can fight him, but let's actually not do that. Gonna get out of here. Cool. So that's what we have set up today. Let's go and see how all of this is built. As you remember, we have our axe wielder prefab here. Not many changes happened here. Tweaked a little bit the speed, so the enemy is a little bit faster. We still have the cooldown damageable script here that's gonna be handling all the different behaviors here. The only thing that has changed has been the on-death event here that's now triggering the death handler in the enemy behavior, but we'll see that in a minute. And then also added an instant spawner script, much like we have for other non-attacking damageables, like the pine trees. They also spawn here, and it's configured the same way. It has a generic spawner prefab here and a spawner config here. We're using the same log spawner as the pines, but we can swap that out for better loot later on. Cool. So let's jump into the code real quickly. Here we are in the enemy behavior. A few things have changed here. It's actually way more complex now. There's been a lot of tweaking happening here. I'm still not 100% happy with how everything's set up, but it's actually a lot better than it used to be. But we'll go through everything and we'll see what has changed. First, as you saw, we now have the enemies be able to detect the player, and that's handled with the player detectors here. You can see here that we get the player detectors from the children of the enemy, and then we have each detector called the setTarget method here whenever the detector detects the player. This setup allows us to set multiple detectors per enemy, so we could have enemies that can look in different directions or have different ways of detecting the player. Just basically imagine you can have one detector per eye, so you could have an enemy that's just looking in one direction, or you can have an enemy that's looking in numerous directions or has different ways of detecting the player. The player detector here is set up really simply. Whenever the detector, which is a trigger, has a collider stay inside of the trigger, we check first if we're already targeting something, and then if we're not, we start the active target coroutine here. And the active target coroutine is simply first setting up the is targeting to true, so we don't trigger this multiple times. And then in a while true loop, so this loops forever. First is doing a raycast here from the current position of the detector into whatever the target position was. So we're here just raycasting into the collider that is inside the trigger. And we have a max distance to target here. If that raycast doesn't hit anything, then we set the targeting to false and we break out of this loop. So if at any point we lose the target, then we just get out of this infinite loop and then reset to be able to trigger something else. But if we do get a hit, we check for the player component here. So anything that has a player controller could be targeted by this player detector component. If whatever we hit, however, is not a player, then we also break out of this loop and set the targeting to false. If we did indeed find a player though, we call the onDetect callback with the transform that we hit. And then at the end of each loop, we do a little waiting cooldown so that we're not constantly targeting, but we have a little break in between. And this onDetect callback that we have here is what the enemy behavior here is hooking onto. So we have the setTarget getting called whenever one of the detectors finds a player. So we'll see that setTarget in a second. For now, let's go through the regular state handling. So at the very beginning, we set the state of the enemy to idle, because all enemies start as idle until they detect the player. And then in the update loop, we are constantly updating the state of the enemy. First, we set the agent movement. This is a change from the previous video. Now we are setting the navmesh agent to move only when we are in the is running animation. This way, there's no way for the navmesh agent to move unless we are actually in the running animation. This prevents a lot of issues with the enemy sliding around while in some transition or something like that. It makes the enemy a little bit slower to react to many things because it cannot move as much, but this makes the whole animation a lot smoother. Then, if we are in the idle state, we simply set the moving boolean to false to make sure that we are not in the running animation, and then return. For the most part, when the enemy is in the idle state, we're really not doing anything. We're just waiting for something to happen. If, however, we are in the attacking state, then we set the boolean to false and we reset the attack triggers. This is mainly done to make sure that we're not constantly attacking, that we get out of the attack loop. So this is a bit of a helper method, so to speak. Then we also have a different helper here, that we have a should stop boolean. If at any point we need to set the moving boolean to false to get out of the running animation, we can set the should stop to true, and then on the next update loop it will set the boolean to false. Now here are the more interesting states. If we are not in the attacking state and the target that we have selected is in range, then we do one of two things. If we detect that the target is in front of the enemy, then we simply set the state to attacking, we'll set the boolean of moving to false so that we get out of the running animation, and then we start one of the random attacks, either the horizontal or the vertical attack that we have selected that we saw in the previous video. This way the enemy is not moving around when we are attacking. If, however, the target is not in front of the enemy, if it's, let's say, behind the enemy, then we set the state to chasing instead of attacking. We set the moving boolean to true, and then we call the face target method so that the enemy turns around and faces the player in this case. Otherwise, if we are in the attacking state and we have finished the attack, which we can see here, is basically checking for the animator to see if we have moved out of any of the attack states. For example, if we are in the idle or the running state, or transitioning. And then we say, hey, if we are idle or running and we're not transitioning, we consider the enemy to be done attacking. So if the enemy was attacking but is now done, then we set the moving boolean to true so that the enemy can move again, and then we go back to the chasing state. We assume here that the enemy attacked the player and the player is not dead, so we want to make sure the enemy can attack the player again. But if the player has moved out of range, we want the enemy to chase down the player. So we cannot just assume that the player has stayed in range. That's why we're moving to the chasing state, not to the attacking state. Then if we are in the chasing state, we again make sure that the moving boolean is set to true, and we're checking whether we still have a target to follow. We check this with the agent path done method that basically checks whether we still have a valid path for the navmesh if we haven't reached the end of the path for the navmesh, and if we are still moving. If we get to a point where we have reached the end of the path, that means that we don't have an active target to the player, we lost sight of the player, then we move from the chasing state to the searching state, and we set a timer here to finish the search. So we can only be in the searching state for so long before we get out of the searching state. And then if we are in the searching state, if we've moved through all the other states and we're in the searching state, then we're checking, have we reached the end of the timer? If so, we reset the target, we reset the has target boolean here as well. We move to the idle state, we stop moving and we stop searching. Otherwise, if we're not done with the search timer, then we set moving to false because we are just looking around now, but we set the searching boolean to true. And you saw that here in the animator. Well, you saw it in the demo before, but now we have this looking around state that, as you can see here, is just an animation of the enemy kind of looking around. And one thing we didn't see before, but we can see here in the enemy, here is that now we have this detector. The detector is actually parented to the head. So the detector moves with the head. So you can see here, I can put it here. We select an animation. Let's say the looking around animation here. It should be a bit more obvious. that when the enemy is looking around, the detector also moves. So it follows the gaze of the enemy. And that's how, when the enemy is looking around, it can find the player even if the player is slightly behind. You can see there the enemy is turning around, or at least looking back. You can still hide behind the enemy, but not so well. Like it will still find you unless you're like pretty much strictly behind the enemy. But that's cool. So when we get to that searching state, then we can here find the player again with this searching movement or searching animation here. And much like all the other states, it has the option to go back to idle when we're done searching, and it also has the option to go to hit react. So if you hit the enemy while it's searching for you, it will still react properly. So that's the searching state. It has a timer so that we are not searching forever, but it has that extra opportunity for the enemy to find the player. And the rest of the enemy behavior is pretty similar. There's a few changes here. Here in the got hit handler, we're still setting the source of the hit both on the right and the front. We use the hit source right parameter to do the blend animation for the different hit reactions, and we do the hit source front parameter to do the blend animations for the death animation that you saw before. You can probably see it here. We have a couple of animations here for the enemy dying, falling backwards or falling forwards. So we use that parameter to determine whether to fall forwards or backwards. And the rest is pretty much the same, just making sure that we enter the cooldown state here so that you cannot hit the enemy multiple times while it's in the hit reaction animation and all of that. We set the should stop to true so that whenever we go out to the loop, we stop moving. And then we set the enemy state to chasing so that it can, if the enemy is in front of the player, the enemy can immediately start attacking. And even if the enemy is, or if the player is behind the enemy, setting the state to chasing means that on the next cycle, it will move to searching, and then it'll trigger the search animation. So even if you hit the enemy from behind, it will then look around and try to find the player. It won't immediately find the player just by the player aggroing the enemy. It will move into a search animation, and if within the search animation it finds player, then it will attack. Then we have the hit cooldown coroutine. This is pretty straightforward. It's just a counter for however many cooldown seconds we define, and then resets the cooldown to false, so we can hit the enemy again. These are the helper methods to determine whether we're hitting from the right or the left, or from the front or the back. The only difference here is that for the back, we are rounding this down to 0 or 1. That's because the blend tree for the death animations behaves really weirdly if it's not fully falling backwards or fully falling forwards. The blend animations between the two states just doesn't look good. So here we're using this parameter to choose between one of the two animations, but not really blending between them. Then you have the set target method here. This is the one that's tied to the player detector callback. So whenever the player detector finds the player, it sets the target to the player, sets the has target to true, so we can use that boolean in other methods. Then it sets the navmesh agent destination to the position where the target is, so basically to follow the player. Sets the searching boolean to false, so we get out of the searching state if we were searching. And then if the enemy was either idle or searching, it moves to chasing. This prevents the enemy from, if it's attacking, from going to the attacking state to the chasing state while it's still attacking. Then you have the agent path done. We already covered this, but it has a number of checks to make sure that we have a path and that we are still not at the end of that path or we're still moving. So if it fits any of these conditions, then we say, hey, like the navmesh agent actually doesn't have anywhere else to go, so we trigger the searching state. Target in attack range, this is pretty straightforward. We're just calculating the distance from the enemy to the target, and if that is less than the attack range, we attack. This could be a lot smarter, but for now we're just keeping it very simple. The face target method here is actually not super great. It could be a little bit better, but it's basically just getting a look rotation from wherever the enemy is to wherever the target is. And then we are doing a linear interpolation or a spherical linear interpolation, otherwise called slurp, between those two rotations so that the enemy slowly moves around to face the player. In reality, this angular speed that the navmesh agent has is fast enough that the enemy turns around almost immediately. So we could be tweaking that a little bit better to make the enemy turning around to face the player a little bit slower. But for now, it's working well enough that the enemy turns around to face the player before starting attacking. To determine if the player is in front of the enemy, we first check for the target here, and then we do a dot product. If the vector from the enemy going forward, the forward direction for the enemy, the angle between that and the position of the player is technically in front. And if you can imagine it as two vectors or two arrows, if those are aligned in roughly the same direction, and then it's greater than 1. If they're perpendicular, it's 0, and if they are pointing in different directions, it's gonna be -1. So that's how we determine if the player is in front of the enemy or not. The random attack we saw before is just choosing between the two attacks that we have. Again, if we decide to add more attacks, we'll need to refactor this to do it better, but for now it's working. Here we already saw we're checking if we're in the idle or the running state and not transitioning, and we call that, or we consider that to be done attacking, so we can move to attack again or move to the next state. This one we saw before. If we are in the running state, we allow the nav mesh agent to move. If not, we don't allow the nav mesh agent to move, and that keeps the enemy from sliding around when it's not actually moving. The reset attack triggers does exactly what it says. It just resets both triggers so we don't continuously attack. And then we have the death handler. This is part of the new changes here. When the player kills an enemy, we trigger this death handler. We're just setting the moving boolean to false to make sure that the nav mesh agent is not actually doing anything. Then we set the trigger for is dead, so this actually gets to the animator and triggers from any state into the death state here. And then we start this coroutine called the delay death handler. We do this so that we can allow the death animation or the death animation to play smoothly before doing anything. So we wait a number of seconds here to allow the animation to go forward, and then we invoke the undelayed death event here so we can trigger a bunch of other behaviors, and then we destroy the enemy game object. At some point we'll probably want to, instead of destroying, do some object pooling here so we can have many enemies without having a ton of performance issues, but for now we're just destroying it. And you can see here that we have the undelayed death event, and this is the event that is triggering the item spawning here. So after the player has gone through the death animation, we then instance the different items here that we have, the loot, and then destroy the object, which is what you saw in the demo before. It lays dead for just a second there, and then we spawn the loot and destroy the enemy game object. And that's pretty much what we have. Let's just quickly go into VR again to see it in action now that you understand how it's built, and we'll close it for today. Alright, here we are in VR again. We have the enemy start spawning here. This one is now chasing me, and he's gonna try to find me. If I attack him, he still reacts fine. Then he also gets his attack in. Now we fight. Hopefully I get to kill him, and then lies dead for a second there, and then spawns some loot. Well, let's hide here for a second. You can see now over here that the enemy is looking for me, but cannot find me. So after a little bit of time, it goes back to the idle animation. And now I can attack him. And that's pretty much what we have for today. It's been quite a bit of tuning and tweaking and playing around to get the animator to work kind of okay. It's pretty complicated to set the enemy AI behavior to work properly, and especially when you're mixing animation with nav mesh navigation, it gets really tricky, and it's very hard to get everything to work just right. There's a number of different interactions between different enemy states and the nav mesh agent and hit detection, interrupting animations, all of that. There's quite a bit to cover that I didn't go through even, but we can come back later and do another round of this animation for enemies later, because it's a very deep topic that we can continue to explore. But for now, I'm considering this good enough, and good enough for me to move forward with what's left of the project, just not to spend another week on this. But yeah, we'll definitely revisit the enemy animations and just general enemy behavior later. There's still a few more animations to look into for example, a boss character or something like that, or let's say a higher level enemy that has, actual combo attacks or different attacks that are more difficult for the player. so that we can make it more interesting. But yeah, that's it for now. The next things to cover is the enemy loot to make that actually better. Moving on to setting the different environments, and the next big thing that I'm going to be looking into is setting more of a quest system so that we can set objectives for the player to accomplish. And with those elements, we're basically going to have enough to sort of complete the first stage of this project here. So I'm really excited to get that done and be able to have a fully working scene that you can see everything coming together, because I've been playing around with some scenes with some of the other systems put together, and it's pretty cool. So I can't wait to share all of that with you later. But for now, this is going to be it. Thank you for sticking around with me, and I will see you in the next one. Bye for now.